welcome to today's lesson on measures of position. In this lesson, we will tackle another measure of position, which is the percentile. Our previous topic was about decile, which is also a measure of position. So, as a recall, to how many parts do decile values divide a distribution? Very good. 10 parts. Okay, so for today's lesson, here are our objectives. 1. Calculate specified measure of position for ungrouped data, specifically percentiles. And 2. Perform the given task with accuracy. So without further ado, let's start learning. So what is a percentile? Percentiles are the 99 score points which divide a distribution into 100 equal parts so that each part represents the dataset. So in the illustration in here, we have percentile 1. Percentiles are also used to characterize values according to the percentage below them. Take, for example, the first percentile. It separates the lowest 1%, the yellow part, to the other 99% in the distribution. Another example, for the second percentile, it is placed somewhere here. It separates the lowest 2% from the 99% of the distribution, and so on and so forth. So furthermore, take note that among the measures of position, percentiles are commonly used in presenting the performance of students in an examination. For example, in college entrance tests, or like example, the UP college entrance test, and also the standardized tests like the NCAE. Okay, so this time I've picked some percentiles among the 99 percentiles that we have in a distribution. So this is how we interpret percentile values in a distribution. Okay, so again, these are just some of the percentile values that we have. Take note that there are 99 percentile values that we have, which divide our whole distribution into 100 equal parts. Okay, so if a score falls on percentile 10, it means that, okay, 10% of the distribution is less than or equal to that score. And the remaining 90% of the distribution is greater than or equal to the percentile 10 score. Next, if a score falls on percentile 40, okay, it means that 40% of the distribution is less than or equal to that score, and the remaining 60% are greater than or equal to that score. Next, if a score falls on percentile 50, it means that 50% of the distribution is less than or equal to that score, and the remaining 50% is greater than or equal to that score. Next, if a score falls on percentile 70, let's say, it means that 70% of the distribution is less than or equal to that score, and the remaining 30% is greater than or equal to that score. Okay, so how do we find for the unknown percentile? So we have steps to follow, just like in quartiles and deciles. So step 1, arrange the values in ascending order. Step 2, locate the position of scores in the distribution using the formula. So this is our formula for the percentiles. And if our answer in step 2 is a whole number, no need to proceed to step 3. But if our answer in step 2 is a decimal number, we proceed to step 3, which is interpolation. This is our formula for percentile. P sub k is equal to k times the quantity n plus 1 over 100. P sub k corresponds to percentile. K is our percentile location, and n represents the number of elements in a given data set. Okay, so before I proceed to the examples, let's have this review. In the previous lessons, we talked about the other measures of position, which are the quartiles and the deciles. This time, we will explore again the interrelatedness of quartiles, deciles, and percentiles. On the first illustration above, we have here, we are presented the interrelatedness of quartiles and percentiles. We see that percentile 25 is equivalent to quartile 1, percentile 50 is equivalent to quartile 2, percentile 75 is equivalent to quartile 3. Beginning with percentile 25 and quartile 1, they are equivalent since 25%, diba? We know that quartiles divide our distribution into 4 equal parts. So we have here, each division is 25% of the whole distribution. So 25, 25, 25, and 25. That gives us a total of 100%. Okay. So again, for percentile 25 and quartile 1, they are equivalent since 25% of the distribution is less than or equal to these values, and the remaining 75% is greater than or equal to these values. Moreover, percentile 50 and quartile 2 are equivalent since 50% of the distribution is less than or equal to these values, and the remaining 50%, okay, is greater than or equal to these values. Furthermore, percentile 75 is equivalent to quartile 3 since 75% of the distribution is less than or equal to this value, and the remaining 25% is greater than or equal to these values. Okay? On the second illustration, we see in here the interrelatedness of deciles and percentiles. Percentile 10 is equivalent to decile 1. Percentile 20 is equivalent to decile 2. Percentile 30 is equivalent to decile 3. Percentile 40 is equivalent to decile 4. Percentile 50 is equivalent to decile 5. Percentile 60 is equivalent to decile 6. Percentile 70 is equivalent to decile 7. Percentile 80 is equivalent to decile 8. And percentile 90 is equivalent to decile 9. So, for example, for percentile 10 and decile 1, they are equivalent since 10% of the distribution is less than or equal to these values, and the remaining 90% is greater than or equal to these values. Next, for percentile 30 and decile 3, they are equivalent since 30% of the values in the data set is less than or equal to percentile 30 or decile 3 value, and the remaining 70% of the values in the data set is greater than or equal to the decile 3 or percentile 30 value. Moving on, For percentile 50 and decile 5, they are equivalent since 50% of the values in the distribution is less than or equal to percentile 50 or decile 5 value. And the remaining 50% of the values in the distribution is greater than or equal to percentile 50 or the decile 5 value. Okay. Also bear in mind that quartile 2, percentile 50, and decile 5, they are all equivalent or of equal value, and they are considered as the middle score of every dataset. Again, quartile 2, percentile 50, and decile 5 are all of equal value, and they are considered as the middle score of every dataset. Okay, this time, let's have an example for percentiles. Given, we have the following values: 1, 3, 7, 7, 16, 21, 27, 30, and 31. We have to find for the percentile 50 value, and we have to interpret the result. So, for the steps in finding for the unknown percentile value, we have to first arrange the values in ascending order. Step 2, we have to use the formula to locate the position of scores in the distribution. If our answer in step 2 is a whole number, no need to proceed to steps 3. But if our answer in step 2 is a decimal number, we have to proceed to step 3, which is interpolation. Okay, so first let's find percentile 50 value. So first step, arrange the values in ascending order. So we have 1, 3, 7, 7, 16, 21, 27, 30, and 31. We simply copy from the given because it's already arranged in ascending order from least to greatest. Step 2, locate the position of percentile 50 value in the distribution. So we have here the formula for percentiles. P sub k is equal to k times the quantity n plus 1 over 100. We are looking for percentile 50. Therefore, for our given k is equal to 50, okay, percentile 50 is of the form p sub k. So p and p, so k then is equal to 50. So we have here k is equal to 50. Let's say we are looking for percentile 10. So k will be equal to 10. If we are looking for percentile 5, fifth percentile, let's say, so k is equal to 5. If we are looking for percentile 50s, so k is equal to 50. If we are looking for 75th percentile, so k is equal to 75, and so on and so forth. Okay? And n is equal to 9 because there are 9 values in our data set. So we now substitute the given to our formula. So for our position of the 50th percentile, we replace k by 50. So we have here 50 times the quantity. We replace n by 9. So we have 9 plus 1 over 100. We perform the operation. 9 plus 1 is 10 times 50. That gives us 500 divided by 100. 500 divided by 100 is 5. So we have in here, since our answer after using the formula is a whole number, which is 5, there's no need for us to proceed to step 3, which is interpolation. Thus, we say that the percentile 50 value is located in the 5th position. So going back to our arranged values in step 1, we locate the 5th position. 1, 2, 3, 4, 5. This is the 5th position. So therefore, percentile 50 is equal to 16. Okay. As you can see in here, 16 is the middle score. There are 4 scores below it and 4 scores above it. It's the middle score, percentile 50. So for our interpretation, a score of 16, which falls on percentile 50, means that 50% of the values in the dataset are less than or equal to 16, and the remaining 50% are greater than or equal to 16. Okay, So that's all for our first example. Let's have another. Find the 25th percentile and the 75th percentile scores and the following test scores of a random sample of 10 students. 35, 42, 40, 28, 15, 23, 33, 20, 18, and 28. And then we interpret the results. Okay, so first let's look for the 25th percentile value. So step one, we arrange the scores. So we have here 15 is our lowest score and 42 is our highest score. Second step, we locate the position of the 25th percentile value in our distribution. In here, we will be using a formula. So again, this is our formula for percentile. And we're looking for the 25th percentile. So K will be equal to 25, right? And N is equal to 10 because there are 10 values in our data set. We substitute the given to our formula. So we have position of 25th percentile is equal to, we replace K by 25. We have here, we replace N by 10 here. And then we copy the rest, plus 1 over 100 plus 1 over 100. We perform the operation. 10 plus 1 is 11. 11 times 25, that gives us 275 divided by 100, that gives us 2.75. So since our answer after using the formula is a decimal number, 2.75, we need to proceed to step 3, which is interpolation. So our percentile 25 value is located in the 2.75th position. To perform the interpolation process, we first locate the 2.75th position based on our arranged values in step 1. So this is our arranged values in step 1. So 2.75th position is between the second and the third positions. So we have 18, which is the score that corresponds to the second position, and 20, which is the score that corresponds to the third position. So in order for us to get the score that corresponds to the 2.75th position, we have to add the second score and the 0.75th score. So percentile 25 value is equal to 18 plus 0.75 times the quantity 20 minus 18. 18 here is our second score, and 0.75, the expression 0.75 times the quantity 20 minus 18 is our 0.75th score. So 2 plus 0.75, that gives us 2.75th score, which corresponds to 2.75th position. By the way, 0.75 here came from our answer in step 2, which is 2.75, the decimal part of our answer in step 2. Okay, then 20, of course, this is our third score, and our 18 is our second score. So we perform the operation. We have 18 plus 20 minus 18, that gives us 2 times 0.75, that gives us 1.5. So 18 plus 1.5, that gives us 19.5. Next, we look for the value of percentile 75. Step 1, we arrange the values in ascending order. We have again 15 as our lowest score and 42 as our highest score. Then we locate the position of percentile 75 value in the distribution using our formula. So we have our formula here. So we're looking for percentile 75. So K is therefore equal to 75. And N is equal to 10 because we have 10 values in our data set. We now substitute the given to our formula. So position of percentile 75 is equal to 75. This is our value of k. And we replace n by 10. Okay. And then we copy the rest from our formula, plus 1 over 100, plus 1 over 100. We perform the operation. 10 plus 1 is 11 times 75. That gives us 825 divided by 100. So we have here our answer, which is 8.25. Since our answer after using the formula is a decimal number, 8.25, we need to proceed to step 3, which is interpolation. By the way, our percentile 75 value is located in the 8.25th position. Okay. So to perform the interpolation process, we first locate the 8.25th position based on our arranged values in step 1. So 8.25th position is between the 8th and the 9th positions. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So our 8th score is 35 and our 9th score is 40. So 8.25 is somewhere here. Okay. Now to get the score that corresponds to 8.25th position, we have to add the 8th score and the 0.25th score. So percentile 75 value is equal to 35 plus the quantity, plus 0.25 times the quantity 40 minus 35. 35 in here is our 8th score, and the expression 0.25 times the quantity 40 minus 35 is our 0.25th score. So 8 plus 0.25, that gives us 8.25. So 8.25th score corresponds to 8.25th position. Okay. The 0.25 in here, in our 0.25th score, came from decimal part of our answer in step 2, okay, which is 8.25. So we took the 0.25 part for our 0.25th score. And of course, 40 is our 9th score and 35 is our 8th score. All right, so we perform the operation. We have 35 plus 40 minus 35 is 5 times 0.25. That gives us 1.25. So performing the operation, percentile 75 value is therefore equal to 36.25. Now we go to the interpretation of the results. So percentile 25 is located in 2.75th position, and so it is equal to 19.5. So it's somewhere here. So if I score of 19.5 falls on percentile 25, it means that 25% of the students obtain a score which is less than or equal to 19.5. And the remaining 75% obtain a score greater than or equal to 19.5. Furthermore, a score of 36.25, somewhere here, which falls on percentile 75, means that 75% of the students obtain a score which is less than or equal to 36.25, and the remaining 25% obtain a score greater than or equal to 36.25. Okay. So that ends our lesson for percentiles. To recap what we have just discussed, percentiles are again the 99 score points which divide a distribution into 100 equal parts. These are the steps that we undergo in order to find for the unknown percentile values. Step 1, arrange the values in ascending order. Step 2, locate the position of scores in the distribution using the percentile formula. If our answer in step 2 is a whole number, no need to proceed to step 3. But if our answer in step 2 is a decimal number, we have to proceed to step 3, which is interpolation. So this ends our lesson for today, everyone. Hope you've learned something. Thank you so much and see you next time. Bye.